Okay, welcome back everybody. Happy Thursday. Today is March the 9th. We're going to finish up lesson 14, which we started last class. So we're going to tackle lesson 15. You can see here in the bottom row, lesson 15 is integer exponents. So again, we're kind of in the starting stages of our big long section on exponents and radicals. I've also highlighted March 14. That's our very next meeting on Tuesday, and that is our very first test. We have 2 tests this semester plus the final exam, and then the smaller quests in between. So this first test is coming up on Tuesday. You can see right above the highlighted stuff here, it covers lessons 1 through 13. That was everything we covered up through the beginning of our last class, but not the stuff on exponents, and not today's stuff on exponents either, all right? It's really easy to know what's on the test. It's everything from that first packet and nothing from the second packet. That's how the packets were created, all right? Okay, so as you prepare for the test, keep in mind you are welcome to use a reference sheet of your own creation, 1 page front and back. You can use both sides, so you can write anything you want on there, theorems, definitions, formulas, practice problems worked all the way out. If a particular kind of word problem is troubling you, go find one, put it on your paper with a complete step-by-step solution written. Serena. Exponents is not going to be on the test. In terms of these word problems here, you know how we had 2 days of word problems that resulted in systems of equations? The first day, the word problems were a little bit easier than the second day. So I will give you a little bit more specific information on this test coming up. On one of the questions, you're going to have a choice of 2 word problems, both that we covered in day number 1. You're going to pick one of those 2. And another question is going to be a choice. You're going to pick one of 2 word problems from day 2. All right, so you're definitely going to have to tackle one of the easier kinds of word problem setups and one of the harder ones. It will be the only opportunity on this test where you'll have some choice to make. Yeah.
Do we also have to do one substitution?
You will have to, I don't remember. But I really want you to know how to do substitution and elimination. I'm pretty sure there's something on there that like 2 systems and it says you have to use 1 substitution and 1 elimination, and you can decide which one you want to use on which system. So you definitely need to know how to do both. Okay, so again, in terms of resources for the test, you've got the packet, the first packet, you've got your textbook, you've got your homework problems, you've got your quests. I think those are really good sources of problems. And there's also that practice problems packet. Make sure that you take a look at those. And remember that the practice problems packet has complete solutions in color up on Moodle. There's a PDF up there you'll find, and also you'll find on YouTube a playlist of me solving each of those questions, all right? Anything else before we move on to exponent stuff? Okay, so let's jump in here on page 121. In this lesson, we tackle negative exponents. We didn't see any of those last class. Scientific notation and roots, like square roots and cube roots and things like that. Okay, so we've got this table here, and we had this property that we wrote down last time. We said any number raised to the 0 is equal to 1, right? Any number to the 0 is 1. And that's kind of a strange thing for some students to accept. How might you define a number like 3 to the 0 if you didn't want to define it to be 1, if you had just a complete choice? 0 times. Right, so then, so like maybe 0, maybe itself. Yeah, I mean it's 1. So let's figure out. All right, you go. We're good. All right, let's figure out why defining a number to the 0 to be 1 is an appropriate way to define a number to the 0. Okay, let's take a look at this pattern over here on the right-hand side. We'll start here. 3 to the first, that's 3. 3 to the second is 9. 3 to the third is 27. 3 to the 4, 81 is good. Okay, easy, so far so good. In order to work our way up the chain, we have to multiply by 3 every time. Agree? Times 3, times 3, all the way up, yes? So if we're going to work down the chain, we should be dividing by 3, right? And that works perfectly well over here. Divide by 3, 27 divided by 3 is 9, 9 divided by 3 is 3. Keep going with the pattern. 3 divided by 3 is 1. And so just looking at the powers on the left-hand side, 3 to the 4, 3 to the third, 3 to the second, 3 to the first, 3 to the 0 is the next natural thing in that pattern. So if I'm gonna follow this pattern, which seems perfectly reasonable, then I better define 3 to the 0 to be 1, but there wasn't anything special about 3. Any number to the 0 should be defined to be 1 because any number is going to have this pattern when you write out the powers. Okay, but that was so much fun. Let's keep going. Again, we're dividing by 3 to go down this ladder. 1 divided by 3. I'm going to leave this as a fraction. Like you could write it as a decimal, but I'm going to write everything as fractions here. So that's 1/3. Okay, now it's a little bit trickier. We're going to again divide by 3. Yeah, if we do 1/3 and we divide that by 3, you guys remember, whoops, we don't need to write this part, but remember division changes to multiplication, and then you take the second guy and you flip it over. Remember doing that? So 1/3 divided by 3 is the same as 1/3 times 1/3. And then we multiply fractions straight across. 1/9. There. And we're going to divide by 3 again, and we're maybe starting to see a new pattern here. What's the next one going to be? 1/27, right? I can just see the powers of 3 living down there in the bottom and a 1 on top. And then the last one, 1 divided by 81. And so this gives rise to negative exponents. So we just saw why 3 to the 0 should be defined to be 1, but following the exponent pattern, squared to the first, to the 0, to the -1, to the -2, -3, and -4, I better define these negative exponents to be these fractions over here. And so just as just like one example, 3 to the -4 is really the same as 1 over, what's another way to say 81? 3 to the 4, isn't it? Right, 3 to the 4 is 81. So 3 to the -4 means 1 divided by 3 to the +4. So when you see a negative exponent, you just automatically say, oh, it just means 1 divided by the same thing, but with the positive exponent. That's what the pattern is telling us. And so that is written out right here. X to the -n means 1 divided by x to the +n, right there. It turns out if you have a negative exponent in the bottom, you can flip it right back up to the top. So if you have an x to a negative exponent on the bottom, flip the whole thing over, put it right up on top. So 2 examples over here. If you see 3 to the -2, you just say, oh, that's 1 over 3 to the +2, which is 1/9. And then if there's a 3 to the -2 on the bottom, you'll bring it upstairs and make it a positive exponent. So that's the same as 3 squared, which is 9. All right, little shortcut for negative exponents. Negative exponents indicate movement. If you see a negative exponent in a numerator, you make the exponent positive by moving that particular term to the denominator. If you see a negative exponent in the denominator, you make it positive by moving the term into the numerator. So we're going to see that in play with this example here. The solution's actually already written out there, but we're going to do all the work on our own here in this blank space. So ignore the solution that's typed up. And if you don't mind just copying that thing right here. Okay, turns out with these exponent problems, there are oftentimes multiple ways to do the thing right, but also lots of ways to do the thing wrong. So we're going to pick one way to do it right, but recognize this is not the only way. First thing that I see that I want to resolve is the parentheses. Parentheses means there's more work to do. So let's do something that gets rid of those parentheses. We have seen a property last class, which tells us that there's a little shortcut you can do with the 3 and the -2 when you have exponents that look exactly like that. Add, subtract, multiply, or divide those 2 powers. Let's multiply. Do you guys remember this shortcut? We saw it last time. D to the third to the -2, we get to multiply those powers. So I'm going to copy everything else. And I'm going to multiply these powers. So it becomes d to the, -6. No more parentheses. So I feel like that's better than it was before. We'll move this up a little bit higher. D to the -6, no parentheses. So we multiply those exponents. Okay, the next thing that I do, and again, this is not the only choice, is I make all of the exponents positive by moving stuff around. So the 5, I am copying. Oh, I'll just give a big fraction line here. The 5 is upstairs. It has no reason to go anywhere, so we just copy it. The r to the -9, does it have a negative exponent? Yes, negative exponents mean movement. So we are going to move the r to the -9 where? Downstairs to the denominator, and it becomes r to the +9. It's not r to the -9 anymore. When you move it, you take care of that negativity. Okay, I've got nothing else upstairs, so we move downstairs, and we're just going to take each factor one at a time and put it where it belongs. 25, it has no reason to move. Put it right there. R to the -5, stay or move? Move, it's negative. So we move it. It used to be downstairs, it goes upstairs and becomes positive exponent. D to the 8, stay or move? It stays, it's a positive exponent. Don't go crazy. You don't move everything, you're only moving the things that have negative exponents on them. D to the 8, it's just d to the 8, it doesn't go anywhere. How about the d to the -6, stay or move? Move, and it moves upstairs, d to the 6th. Okay, so I like this a lot better. It seems more user-friendly, at least as far as I'm concerned, because negative exponents are tricky for me. So now they're all positive. I'm a lot more comfortable here. Okay, let's start reducing. First, the 5 and the 25. We can reduce those. 5 becomes 1. 25 becomes 5. Okay, so far so good. So we're actually about to write our final answer. I'm going to put that 5 downstairs. You don't need to put the 1 upstairs, but you can. Okay, now we're going to start reducing these powers here. We have another property. We have r to the 5th on top and r to the 9th on the bottom. What do we do with those powers? Add, subtract, multiply, or divide. That's a subtract. This was one of our properties from last class. When you have division like this, you keep the base, you keep the r, and you subtract those powers. Now, you could do 5 minus 9, but that gives us a negative exponent, and we just worked really hard to get the exponents to be positive. So instead, what I always do is subtract in the easier order, big minus small, in this case 9 minus 5. So that's 4 left over. Where will the r's be left over, on top or on the bottom? It's going to be on the bottom because there are more r's down there. Like if you imagine r to the 5th, r, right? 5 of them. And downstairs, 9 r's all laid out. We're going to cancel all 5 from the top, and how many will be left over? 4, and they'll be on the bottom, because that's where there are more of them. So r to the 4. Okay, and then the same technique here with d to the 6th and d to the 8. You subtract them. D to the 2nd, where? On the bottom, because that's where there are more of them. D to the 2nd. And that's it. 1 divided by 5, r to the 4, d to the 2nd. Questions on that one? Yeah, exponents are tricky. Okay, let's move on to the next page. And we'll take a quick look at scientific notation here. Scientific notation allows us to easily work with very large numbers or very small numbers. We write numbers in this format, scientific notation that is, by writing a number between 1 and 10 multiplied by a power of 10. That's the definition of scientific notation. It's a number between 1 and 10 multiplied by a power of 10. So let's take a look at this. On a particular date, the US national debt was approximately this number. All right, that number is annoying to write out, or to type in my case. It's also annoying for the reader, because I can't look at that and immediately say, oh, that's 15 billion or 15 million or 15 trillion. I really have to sit there and carefully count digits, right? Which is annoying and prone to error. By the way, what is the name of that 15 there? That's trillion, right? We got you got the hundreds, the thousands, the millions, the billions, and then the trillions. Okay. And so we're going to rewrite that number using scientific notation. Here we go. We're going to look at that number and we're going to move the decimal point. The decimal point is currently here. You need to move that decimal place to the one spot where you have a number that is between 1 and 10. Now, some of us have a lot of practice with this and we're already very good at it, but for the rest of us who don't have a lot of practice, let's just kind of arbitrarily like put the decimal point somewhere. Don't do this just yet. We'll write it down when we get it to the right spot. But if I read this number, point, lots of zeros, I don't care about that. But what is this number if you read it out loud? 15,460. 15,460. Is that number between 1 and 10? No. So haven't gotten there yet. What if I decide to put the number right here between the 4 and the 6? Read this number. 154.6 is getting smaller, but it's still not between 1 and 10. Where's the right spot to put the decimal? It's between the 1 and the 5. Because that number is 1.546, and it is between 1 and 10. That's the winner. If you went a little bit too far, read that number. 0.1546, which is less than 1. That's not between 1 and 10. So you put it right there. 1.546. You don't need to write any of those trailing zeros. Times 10 to some power. Yeah, and now we got to count, and we know that multiplying by 10 just moves the decimal place however many spaces to the right. So we just got to count how many spots did it have to go. We got from here to here. 3, 6, 9, 12, 13. 13 is good. 1.546 times 10 to the 13. And writing the number that way has some advantages. It's easier to write, right? It's fewer digits that had to be written or typed. And it's also easier to read. We don't have to sit here counting digits. And if you happen to know that 10 to the 12th is a trillion, then immediately you know that that is 15 trillion. Okay, next one. The diameter of a typical bacterium is about 0.000000241 meters. Very small. We're going to rewrite that number in scientific notation. Okay, same idea. We want to put the decimal point in the one spot that's going to give you a number between 1 and 10. Where is it going in this case? 2.41. Do you see it? If you put the decimal place here, that's not far enough. That's 0.241. If you put it here, now you're at 24.1. That's too far. So right there is the winner. 2.41 is good. Times 10 to some blank. Yeah, let's count the digits here. Okay, so we're going from here to here. How many spots is that? That is 7 spots. Also note that I did something when I typed this up to make it slightly easier to read. What did I do? Little space where? Every third zero. You can't put commas after a decimal place. Like that's how you can make it easier to read a large number like this. But you can put a space every 3. Okay, so that is definitely 7. Is this the same as this? Yeah, it's not right, is it? I mean, 2.41 times 10 to the 7, that's like 24 million. That's not it. It's negative 7. I could write down something like, make the exponent positive when you want to move the decimal place to the right and make it negative when you want to move it left. But like, it's just not memorable. Use your common sense. Like just count the digits. We're moving 7 spots. Just put a 7 up there and then ask yourself, okay, is it really 10 to the 7? Not in this case. This is a number very close to 0, right? So just put the number and then decide about positive or negative. Okay. All right, so here is the plan for the rest of today. There are 3 activities that follow this one here, and you should have time to get through all 3 of them. That said, I didn't give you enough time to get through the activities last class, so how about we go back to whatever activity you were on previously. I'll go back a few pages and show you roughly where you probably were. Possibly page 116, 117-ish, somewhere in there. So you're going to work through those. If you happen to finish all of those activities, then you jump ahead to the new activities that we just left off. At some point, I'm probably going to ask everybody to jump ahead, even if we're not quite finished here.